Well, thank you all for being here tonight. I wanted to welcome you to the 10th anniversary celebration of Pluto Flyby. This is a truly first for humankind and a seminal event. As you're going to hear, that this mission not only changed the way we thought about these icy worlds scientifically, but it really was one of those things for humankind writ explicitly that so many people employed. We argued many times to how to count the number of people that had been engaged with this mission, and the conservative people were coming up with many hundreds of millions, and some people argued it was well over $1 billion, but a billion people. But that's sorry about that, Freudian slip, I guess. But you know, the other way to measure that is that it's still indelibly burned into people's minds 10 years later. Sometimes I talk to people and they say, so what do you do? And I tell them I work at the Johns Hopkins Applied Physics Lab. And they get this funny look and they say, oh, APL, is that place out there? And I said, no, we're the people that brought you Pluto. And they said, oh, that was cool. And so even 10 years later, you know, that sticks in their brain. And that's one measure of the impact this had on humankind writ large. But a lot of what you're going to hear tonight is what it took to make it happen. It's always interesting for me when I talk to people that aren't in the middle of the business. They read the books and they see the manuals of how you're supposed to execute space missions, and they think it's this nice linear flow, and you just knock off the milestones and one thing happens and then the next thing happens. And for those of us in the business, we know that that's not exactly the way. I was recounting for some students, and I said I could not think of any space mission that had not had at least one near-death experience, technical, programmatic, political, and many had several. And you'll hear that this one had, yeah, he's holding up a number of figures. We had all of those kinds. You know, Churchill was not a rocket scientist, but he could have been speaking about our business when he said in the dark days of World War II that sometimes our best is not good enough. Sometimes we have to do what is necessary. And so what you're going to hear for the rest of the program this meeting is from the folks that can tell you what it took to do this, and they did what was necessary. So with that, I'm going to turn it over to Mike, and he's going to moderate our discussion.
Micah, thank you. So I'm Mike Buckley. I am the communications lead for the New Horizons mission here at the Applied Physics Laboratory. I have the privilege of being the communications lead for the mission of a lifetime. And we called tonight as celebrating a voyage, because that's exactly what we're doing here. But we celebrate this voyage tonight. It's a voyage that started long before the New Horizons launch on January 19th, 2006. And its impact has lasted far beyond the January 2015 flyby of Pluto that we celebrate tonight. It's a project, it's a voyage of dreams and determination and dedication and just discovery. It's never giving up and pursuing a goal and pushing the boundaries of what's possible. And tonight we just, and having fun. Having fun while doing it. Thank you, Fran. Tonight you're going to hear from a few of the people. Tonight you're going to hear from a few of the people on the team, just a few of the people on the team that will take you inside that voyage, that journey to get New Horizons to Pluto. So tonight we're going to hear from Alan Stern. He's the principal investigator of the New Horizons mission from Southwest Research Institute. Tom Cremegis, the Space Department head emeritus from the Applied Physics Laboratory. Glenn Fountain, the project manager for New Horizons from the Applied Physics Laboratory. Alice Bowman, the mission operations manager, the mom, from the Applied Physics Laboratory. Hal Weaver, who was the project scientist for New Horizons from APL during the flyby. And of course, we've heard from Mike Ruszkiewicz with his opening remarks. I want to point out, too, before we even get into the discussion, the images, the stunning photos that you saw of the team from behind the scenes that were playing before we started here. Those are the work of Michael Salori, photographer who was with this mission from the beginning, in the clean rooms, through the flybys, to afterward. So if I could, Mike, can you stand up, please, Michael? Thank you for that. So what we'll do is we'll have each of our panelists tell just a little snippet of their story, and then we'll hope to have some time after that to open it up for questions for you and from some of the folks that are online. So with that, I will start with Alan Stern.
And Mike has been our public affairs guy all the way through, all the way across the solar system, even before we launched. How about a round of applause for this guy? So I do have a few slides and a few things that I want to say, but before that, I have two great privileges, and one of them just came up today. Now, where is Caitlin? There she is. Okay, Caitlin Shearer came on board this project late last year under Helene Winters, who was our project manager. And when Helene went on to do other things, Caitlin stepped into that project management job running the project. But some of you who may not be with NASA may not know this, but for missions like New Horizons, NASA has to approve a project manager. So I asked Caitlin to come in and be acting, primarily because I thought it'd be good for NASA to warm up to Caitlin, get to know her in the job rather than just approve a CV. So after we got past some big things we had to do in April, we submitted the paperwork. And today I found out from NASA headquarters on the 10th anniversary of the Pluto flyby, Caitlin is now officially the New Horizons project manager. The other great privilege that I have today is to introduce Louise Proctor, who probably needs no introduction, especially around APL, but Louise has stepped into the NASA headquarters Science Mission Director to lead the exploration of the solar system for NASA. And Louise was kind enough to take some time out of what is a crazy schedule to come and talk to us on this 10th anniversary. So Louise, come on up.
Thank you, Alan. And I'll make this quick because I know you want to hear from these guys. I was thrilled to be here in the K Center with many of you during New Horizons flyby 10 years ago. I'm very pleased to be here now in a different capacity on this 10th anniversary of that landmark event. A decade ago, for the first time, Pluto was revealed not just as a blurry dot of light, but as a complex dynamic world with ice mountains and flowing nitrogen glaciers and a heart-shaped region that captured our own hearts. The Pluto flyby was a triumph, not just of technology, but of vision and of persistence, right? You know this very well. From its inception to the historic flyby a decade ago and even beyond, the mission reminded us all that space exploration is a long game, but it's one worth playing. So to the New Horizons team, scientists, engineers, navigators, communicators, all of you who played your part. You didn't just send a spacecraft 3 billion miles across the solar system. You made history. You rewrote textbooks. Kids in school are learning about Pluto because of what you did, right? There's no mean feat. And it's an immense privilege to even be here with you all today. So you proved that with enough ingenuity and patience, even the smallest world can tell the biggest story. So on behalf of NASA's Science Mission Directorate and all who are inspired by exploration, I congratulate you, this remarkable team. Thank you for proving that when we aim far and think boldly, there are no limits to what we can discover, and that exploration will always surprise us. Thank you.
Thank you again, Louise. Those were beautiful words. So now I have to figure out, oh, here's the clicker. Okay, I guess that's going to work. So I just have a few slides. I'm not going to talk very long. And in fact, that's the good news. I'm not going to talk very long. The bad news is Mike asked me to talk twice tonight. So I'll be up with a few more slides later. So you have to put up with that. But I mostly want to talk to those of you who worked all those years on New Horizons and made it shine so spectacularly 10 years ago today in our biggest triumph. It was a long journey. In some ways, it began in the late 1980s with a group of young scientists who just wanted to see that unfinished business from Voyager, the exploration of Pluto, take place. It took 17 years to get the money. and countless reversals and restarts and so forth. It also took a proposal competition in which our team, New Horizons, APL, Southwest Research, all of our partners like all the university co-investigators, for example, were the underdogs, the very great underdogs. And yet we produced the winning proposal. It's APL's first outer planets mission. In January of next year, 6 months from now, the spacecraft will be 20 years in flight, and it's working perfectly. No part of the spacecraft is broken. And from a technical standpoint, we have the communications range and the power and even the fuel to keep operating and learning new things and making new discoveries until mid-century. I often tell people in public talks that I expect the spacecraft to be operating in 2050, but don't expect to be operating myself in 2050. It's really an amazing story for APL and for all of us, all the people who put in 7 days a week and 52 weeks a year to get it designed and built and tested and off on its way to what has been a really landmark expedition for science and for the United States and really for our time. And I don't think that's too over the top. So I have a few slides. Oh, it even works. Okay, so that's just the title. Okay, so speaking of which, this is a cartoon that's meant to illustrate that long journey before we got to New Horizons. All that time from 1988 until we got to 2001 when New Horizons got started, in which Pluto mission after Pluto mission after Pluto mission ended up in a dustbin. Not one of them got off the drawing board. And there are a lot of reasons for that. But when the New Horizons team came together, when NASA called for a competition, there was just a magic in it. I think we were the underdogs and it made us work harder. We didn't have the experience of the teams that were associated with JPL and exploring all across the solar system. APL had lots of space experience. And, you know, I remember people telling me when they found out that I was PIing this proposal, even if you win it, you're just going to lose because it's just going to get canceled. And they were right, it did. But we'd been dead before, so we found our way out of that. But it took an amazing amount of persistence. And people like Fran Bagenal and Bill McKinnon were a part of that whole exercise in which we get knocked down and we just get right back up and we're going to do it again and then again and then again. And administration after administration, NASA leadership after NASA leadership. Eventually, we knew we would find the key that would unlock that door. And we did with New Horizons. And it's been completely magical ever since. Now, once we won it, then we had to actually go and do it. And the difficult parts of building this, we were awarded the mission with a phone call from NASA headquarters to me on a payphone. Those things don't even exist anymore. In New Orleans, Louisiana, at a Division of Planetary Sciences meeting on the 29th of November, 2001. And in order to get to Pluto on the schedule that NASA wanted, we had to do a Jupiter gravity assist, and there was only one more Jupiter gravity assist available, or you wait almost a decade for Jupiter to come all the way around the sun. So we knew we were under the gun for schedule. Typical planetary missions, even a lot of Earth orbital missions, take 8, 10, 12 years from conception to launch. We had 4 years and 2 months and no second try. And that's what I meant about 7 days a week and 52 weeks a year. But also, we were asked to do this on a budget that was 1/5, 2 dimes on the dollar compared to Voyager. And that was the other big challenge. So we not only had to beat a schedule challenge, but also invent new ways of doing things. And our team did that. But I call that entire period from 2002 to 2005, when we got the spacecraft delivered down to the Cape late in 2005, the blur. My daughter, Sarah, often tells stories from when she was in high school the same years. I don't remember any of them because I was here all the time, or I was at the Cape, or I was at someplace like Idaho National Labs or wherever. And it was the same for all of us. But what was most amazing was the commitment. And I remember when we first started, and it was time just to write the proposal, Where's Leslie Young? Leslie, raise your hand, right in front. Leslie at the time was, I think, just barely out of grad school. She'd just come to work for Southwest Research. I told her what this was going to involve in terms of total commitment, and she just looked back at me and she said, whatever it takes. And whenever it would get hard, Leslie would say, whatever it takes. And that was a commitment across the entire team. It was really amazing. And we had so many alligators in the water. There were political and technical and supplier issues and money issues and things that would come out of the blue. People that got killed in plane crashes that we really needed. All kinds of just, you can't believe, you can't, this is like a science fiction story, but it was fact. It was our lives. For 4 years and 2 months, it was 100% total commitment. And this team rose to that challenge. And they built a nearly perfect spacecraft. Perfect as I've ever seen. This is it. This is our little bird. This is New Horizons. It only weighs 1,000 pounds. It's the size of a baby grand piano. I like this picture a lot because there are people around us, so you really get a feel for the scale. We built it to be very small and bought the biggest rocket anybody had so that we get the fastest speed to cross the solar system. But this spacecraft, as I said, we are now almost 20 years in flight, and it's performing flawlessly. And so are all 7 scientific instruments aboard. Which is just an amazing testament that we not only had to do it fast and break the mold to find ways to do it inexpensively, but we didn't make any mistakes that cost us the mission or that even hobbled the mission. We navigated all 3 of those challenges simultaneously. And then we put it up on the biggest rocket anybody could sell us because it was the biggest, most powerful launch vehicle of its day, the Atlas V, and we bought the most powerful version of the Atlas V. And actually, we were the first flight of that version. We were only the 10th flight of that whole Atlas line, which has now flown well over 100 flights. But that time, it was really new. This is a very big launch vehicle. It's taller than most skyscrapers in downtown Baltimore. It weighs millions of pounds. And New Horizons was so small up in that payload bay. The white nose cone is 70 feet tall, and we put this thing smaller than a table in it. And so we basically launched it more or less empty. And as a result, we had this blinding speed that got us to the orbit of the moon in 9 hours. And then to Jupiter in record time, 13 months, and all the way across the solar system in 9.5 years. And a big tribute to the Atlas team because they did a spectacular job. And the Atlas wasn't enough for us. In order to make that all work, we had to fit it with a special 3rd stage. Boeing, their main competitor, which itself was, Glenn will tell you, quite a number of challenges because the 2 firms had a lot of IP they didn't want to share, but we wanted them to share enough to make sure it was all going to work. And that worked out too. I'm going to show this picture, which is on our lucky day. This picture was taken on Friday the 13th of January, 2006. It's the day that we fueled the RTG, the nuclear power battery, for this spacecraft. So the spacecraft that you see inside that hatch is sitting in that giant nose cone, and we're up at the top of the assembly building for the rocket on the level where the spacecraft is. And they had us all back away because of the nuclear material and stand behind shields. And they went and fueled it with this hot plutonium dioxide. And then they turned all the bolts and capped it. And then they had already planned this, but there was time to take a few pictures. And I asked to go last. And this is a picture of me in front of New Horizons, literally 2 or 3 minutes before they closed the hatch, and no one ever saw it again. And I just love this picture because it's probably the last picture ever taken of New Horizons itself. Sitting there ready for showtime, ready to start this flight across the solar system, which we launched just 5 days later. And there's the launch at 2 p.m. East Coast time on the 19th of January, 2006, a completely flawless launch to Earth orbit, and then an injection on that trajectory out to Jupiter. The spacecraft came on communications as planned. It was in good shape, had 1 or 2 little minor items to deal with, but those got corrected very quickly. And we really had an almost flawless flight with just very minor issues all the way, which is really, really amazing. I've been on a lot of missions that have had a lot of problems, and this one's been almost spotless. And that's a testament to all of you who worked on this so hard. And it sounds like science fiction, but of course it's not. We really did. We crossed the entire solar system on this red line trajectory that's shown right here. As I said, we went to Jupiter because we needed its powerful gravity assist to speed the trajectory and to intercept Pluto, which we did in the summer of 2015. And for those of you, most of you were here 10 years ago today, when we actually flew past Pluto and got the first high resolution images. And it was magical. This was the best picture of Pluto that anyone had ever taken before New Horizons. This was taken with the Hubble Space Telescope. I was principal investigator of that program. It was in the 1990s. And we were so excited to get these images because Pluto had just been a dot before that. And we could see that, oh, look, there are features on the surface, big, bright things. This is going to be cool if we could ever send a mission there. And boy, did it perform. I like to say the solar system saved the best for last. That's Pluto in front and its largest moon, Charon. There are 4 other very small satellites. Charon was discovered decades after Pluto by a man named Jim Christie, who just happens to be in the audience right there. Stand up, Jim. There's Jim. And there's his wife, Charlene, after whom the name Sharon was actually born. Here. Well, it just got better and better as we got closer and closer images. And I don't have a scientific talk here really tonight, but Pluto is it's the best present under the tree I think we've ever unwrapped. There is more to it in terms of scientific paradigm shifts for a first flyby than we could have ever hoped for. When we had betting pools inside the team for things we would find, people would go to dinner and say, well, I bet this or I bet that. But if we just find 1 or 2 of these things, it'll be spectacular. And then we found many of those things and things we couldn't even have dreamed of. Evidence for an internal water ocean on the planet, for true polar wander. We found that this little tiny planet that should have run out of energy and become a frozen dead world like our moon, Luna, which is larger than Pluto. And yet Pluto somehow has outsmarted all the textbooks. And it taught us lessons that small planets, even out in the depths of the outer solar system where it's really cold and there's no external source of energy, can be incredibly active and incredibly complex. And I think there are going to be more surprises when we fly missions to other planets in the Kuiper Belt. But for me, the bigger surprises came in the human story. I love this picture. On the morning of that flyby, 10 years ago today, this picture was revealed. It's not nearly the best image, but it was the best image by a factor of 10 from anything we'd seen as we were flying up. And you can see the emotion in the room. The biggest, most enjoyable part of it for me actually turned out to be the way this team reacted and the emotion and the camaraderie and the payoff, something that we had no second chances. If it had not have worked, there was no go back. We were going past Pluto literally at 1 million kilometers per day. No way to make a U-turn and give it a second shot. It had to work on the first try, and it did. And for me, it was that human story, which I never expected to be more powerful than the science or even the exploration aspects, yet they were. And this is a picture taken on the lawn, actually across the road there, in a place where there's now a big building. But there was a very nice lawn, and we all went out. And this is the crew of New Horizons. I think Mike was saying something about how many people worked on it. I'll tell you my calculation. I just took the budget and divide by what it cost for an average employee at an average place in the aerospace business. And I calculated about 2,500 men and women worked on New Horizons, its payload, its launch vehicle, the RTG. That's a lot of Americans. The flight crew was much smaller. We were peak at Pluto Flyby when we had to run 3 shifts a day, and there were well north of 100 people, all of them being paid part-time. But it's that crew of people that made this successful. And every one of them, the flight crew, Alice Bowman's operations team, Chris Hersman's engineering team, Glenn Fountain's project team, our science team, Kinetics, our navigation folks, Deep Space Network, Mike Buckley and public affairs team, and all the others that I haven't mentioned just now. They worked just as hard to make that flyby successful as the 2,500 people who worked to get us to the launch pad and off on our way across the solar system. And it really is amazing to me how much spaceflight is about people and teams. No spaceflight has ever been done by a single person. It's too big a thing. Everything in spaceflight is a team sport. And the New Horizons team is incredibly special. I don't think I've ever worked with a better team by a long shot. And now I'm going to close with this picture. And most of you probably know it, a few might not. This is Pluto backlit by the sun. And it's true color. The atmosphere is actually blue. If you look very closely, and maybe on this monitor you won't see it, but in the actual images, you can see mountains on the surface and haze layers with structure. But just the image here of Pluto backlit by the sun is my favorite image from the entire flyby. And the reason for that is that this is the equivalent to me of when the first astronauts who went to the moon on Apollo 8 shot the Earthrise shot. It was so meaningful and changed our perspectives because you can only get this picture if you're on the far side of Pluto, if you've made it work. All those years to build it, fly it, and take that one shot at flyby that had to work on the first try. This is our moment of triumph. It's my favorite picture of the whole thing. It makes me think of all of you. Thank you very much.
Yes, it works. You have just heard a lot of the fun part of what it is to have a mission as challenging as Pluto. But when you talk about science and the technology and the fun of doing it, then you just go forward and you with enthusiasm and you're very happy in doing all that. And I think Alan conveyed that. And you will hear more about that from Glenn and how what my job here is to tell you about the less visible and somewhat behind the scenes events that actually allow you to get to the point where you do the fun part, which is build a spacecraft, to talk about the mission, to talk about the trajectories. We know how to do that kind of stuff, and we revel in doing that. So I had the privilege of being the head of the Space Department back then for several years. And I was busy doing other things. But here is a little bit of the history. I think Alan already showed you the various spacecraft that one mission kind of development that one went through. The very first one that he didn't talk about is that actually when we built, not we, I mean the country built the Voyager 1 and 2 spacecraft, and at that time they were called Mariner, Jupiter, Saturn. The thought was that we would build one more, a third one, and it would be MJP, Mariner, Jupiter, Pluto. It was going to be a copy of one of the Voyagers, and it would go in 79, and you would get that mission. Well, as things like that go, people said, oh, well, we don't have enough money to do that. Let's not do that. And we went through all the steps that Alan pointed out about various studies, about mini Voyagers, about Pluto fast flyby. In the mid to late 90s, however, there was a thought, and that was when Wes Hunter's was the head of planetary, that we would build a universal bus called X2000, and it would do 3 jobs: Europa Orbiter, Pluto, and Solar Probe, with small changes. The person who was my first boss when I came to APR was Richard Kirshner. And at one time, it was said, well, we'll build a spacecraft and we'll just make it a universal bus. And all you do is you change a couple of things, and then it's a lot cheaper. And I remember he didn't say it in my presence, he was carried to me. He said, well, there is only one thing in the human anatomy that does 2 jobs equally well, and it took God to invent it. You can imagine what that is. So that was the lesson I learned. I don't get the power players. Who were they? Office of Management and Budget, OMB. And there were 2 fellows there, Steve Isakovich and Brad Spomberg, who were really taken by the Europa ocean below the surface of the thick ice cover of Europa. And they were really enthusiastic about that. They were pushing very hard. Of course, NASA headquarters, although it was in transition at the time because George Bush had been elected president, and the NASA administrator, Sean O'Keefe, who was an accountant, by the way, wasn't appointed until December of 2001, almost a year later, after the election. Why don't I see the slides in here it is. Congress, of course, via the Senate and House Appropriation Subcommittees on HUD, Human Housing and Urban Development, and independent agencies. And what you remember there is what I have in parentheses. Senator Barbara Mikulski of Maryland was chair of the Senate subcommittee. That was very important. NASA centers, of course, every NASA center was interested in the mission as well. And of course, the planetary science community, which made their wishes known through a committee which was called the Solar System Exploration Roadmap, chaired by Mike Berthon, of the Academy. And there is a note there, article that describes all this back in the Science in 2002. So these are the power players. Now, milestones. September 12, 2000, NASA headquarters cancels the JPL's Pluto Kuiper Express mission, citing increased costs from 350 to greater than 550, and eventually, as Alan pointed out, to 1.4 billion. So that was a big escalation. October 13, Ed Weiler, who was the associate administrator, called me and inquired whether if a Pluto mission was completed, should it be an AO, announcement of opportunity, or an RFP, a request for proposal? And I recommended that it ought to be an announcement of opportunity. Everybody should have a shot at that. But why did he call APL is the question. That's why. You see that symbol? It was called the Near Earth Asteroid Rendezvous. That was a mission, the first one that we did here at APL, that built a spacecraft to go and orbit an asteroid called Eros. And it was the first mission in the NASA Discovery line that started in fiscal year 93. And it made headlines because the cost of the mission was capped at 150 million, launch plus 30 days. That was unheard of because every planetary mission at NASA was costing 500 million plus, more like $1 billion. So you the story in Time magazine. But beyond that, we finished and launched the spacecraft for 117, not 150. And then we had this ceremony after launch in February of 96. The launch was in February of 96. And we gave money back to NASA. You see in this picture, Mr. Dan Golding, who was the associate administrator, or the NASA administrator, and Senator Barbara Mikulski, head of the Appropriations Committee. And I have to tell you that some of our colleagues in both industry and various centers, I got some nasty emails. Nobody ever gives money back to NASA. Shame on you. So anyway, that's why Weiler called APL. And he said, so there we go. Now, on Planetary Society was very active after the cancellation of Pluto, of the Pluto Kuiper Express mission, and delivered 10,000 fan letters to Congress on October 19th. There was a lot of public pressure to really have a Pluto mission, and mostly from kids who knew about the dog in Pluto in Disney's. The key meeting, however, was on October 30 to 31, a meeting of the Solar System Exploration Subcommittee, SSCS, in Pasadena. The group from JPL that was working on X2000, this is the common bus I told you about. I would do all the jobs. It would do Pluto, it would do Europa orbiter, and it would do the solar probe to boot. Explained their plans, and the committee was totally unimpressed and decided that it couldn't be done. And they recommended to NASA headquarters that they proceed with a completed Pluto mission and then a Europa mission when the budget permitted. And of course, history justified that. This is the letter that we sent. I was a member of the committee to Ed Weiler. It says here December 27, but it had been communicated long before that. And he said, explore all possible ways to launch a Pluto and the Kuiper belt in 2004 at the time, and then launch the Europa orbiter at the earliest possible date, consistent with the budget. So what happened next is that on November 20, we had Ed Weiler called and he said, look, can you guys do a quick feasibility study of whether you can actually do a completed Pluto mission for a reasonable amount of money? And by the way, can you come and tell me about the results of the study after Thanksgiving? This was November 20. You remember Thanksgiving is always the last Thursday of November. And on November 29, we actually did give a presentation, and we came up with a Ulysses-style spacecraft with one RTG as power supply, radioisotope thermoelectric generator, at a cost, including reserves, well under 500 million. This is the cover of the presentation on November 29. I remember 9 days after he made the request. What I did at the time is I called my friends, Tom Coughlin, the late Tom Coughlin, who was the NEAR program manager. Andy Chang was the project scientist. Glenn was the head of the engineering department at APR. Ralph McNutt was the chief scientist, and Ralph Gold was the supervisor of the instrumentation group. And that study was done through Thanksgiving and over that weekend. And basically, this is what you saw. That's what we came up with. It was the Ulysses spacecraft. It turned out that Rob Gold and myself were co-investigators on Ulysses, and we knew about that, and we knew it had one RTG, you know. So it was the easy thing to do. So milestones. Remember, I said September 12, NASA cancels the Pluto Kuiper Express. October 13, he called me. We did what we did. And December 20, Weiler announces solicitation for a Pluto Kuiper Belt mission capped at 500 million. So a month after, or less than a month after, 20 days after we made the presentation, they came out with an AO. And on December 22, this gentleman there, Alan Stern, and I had a long conversation, and we decided that we would go in with a joint proposal. You remember that? So and that proposal, of course, was delivered to headquarters on April 4 in 2001. In the meantime, the academic committee that was headed by Mike Burton that I indicated before was working on their recommendation. And even though they hadn't finished their report, they communicated to NASA that their preference was to do the Pluto mission and then Europa. So, as I said, the proposal was submitted in April of 2001. At the end of February of 2001, the Solar System Exploration Subcommittee, we met at headquarters, and Weiler comes in and says that in the new budget to be submitted to Congress, funding for the Pluto Kuiper Express, the previous mission, had been deleted, as well as for the solar probe, and that the Office of Legislative Affairs has notified Congress that Pluto AO is canceled. In other words, if you take it at face value, we were out of business. But he noted that Congress has the right to tell NASA not to cancel the AO. Needless to say, that was a hint if we needed one. So Congress instructs NASA to proceed with the AO and evaluate the resulting proposals. Or else, I'm not going to tell you what the or else was. And you know who, the senator who wrote that letter. So New Horizons was elected by NASA on the end of November of 2001. And Congress funds New Horizons at $30 million in the fiscal year 2002 budget to complete phase A. Now, mind you, Congress gave money to a non-existent project because NASA had canceled the project. So they said, do that. The FY 2003 budget comes from the administration, again with no New Horizons and no money. So Congress, but what the administration proposed was 15 million for a new frontiers line item, initially called Discovery Plus. So Congress was interested in knowing how much money we needed and appropriated 95 million for New Horizons, and directed NASA to declare it as the first New Frontiers mission. After that, the administration gave in and admitted that New Horizons was a real project and that we could go ahead. And there were reports that the Office of Management and Budget was highly annoyed by congressional action and has strong words with the Belton Academy Committee because they didn't propose to have Europa as the first priority mission. And so I was motivated to go and visit OMB and transmitted to them how Congress was very annoyed that they were very annoyed. And the Belton Committee moved forward with a final report. So, conclusion. As you may have guessed, spearheading a new mission is a multi-element enterprise. The key thing is that you have to have compelling science, top-notch engineering, little or no new technology. As we know, people are afraid of new technology developments on which a project may depend, a good management track record, and excellent cost-risk performance. And I dare say, had it not been for the NEAR mission and how successful that was, we would have had a hard time winning this one. Then you have to have the ability to form consensus among all the stakeholders, the science community, the agency sponsors, Congress, and the at-large public. And all of these things came together. Now, there are differences of opinion, and there is many times competing centers, as we all know, about this kind of thing. And there are inevitable fights of one sort or another, and you have to fight. But if you never lose sight of the objective, which is to bring back the best possible science, and our proposal with Alan's leadership and the very strong team that put it together made sure that all of this was really top-notch. And And in the final analysis, however, you need dedicated people, as Alan was pointing out in his talk, who, and at all levels, the scientific, the technical, the political, the institutional, and that's what makes the difference. So here we are. Thank you very much. Glenn, it's your turn.
So I'm going to tell a little bit of the story that Tom told about those 9 days where we came up with that first concept. Here's the picture that we all were looking forward to in January 2006 of the launch of New Horizons. That's kind of the midpoint of what I'm going to talk about. But I wanted to start with this. So Tom brought Tom Coughlin and myself into his office just before Thanksgiving and told us, we're going down to NASA. And I said in 2 weeks, he says 9 days, and tell NASA how to do a mission to Pluto. He didn't say it quite this way, but he could have said, a line from my favorite movie, Casablanca, round up the usual suspects. So Coughlin and I walked out of his office. I turned to Tom Coughlin. I said, he's crazy. Well, you can all see how crazy he was. So we began rounding up the suspects. So one of those first suspects is Bob Farquhar. Bob was well known for figuring out how to get around the solar system. So he could help us understand what kind of a trajectory we would need, what kind of a launch vehicle we'd need, and how much mass we could send. And actually, Alan and Bob Farquhar had written a paper about a Pluto mission like in 1990. So he was that first line up at our suspects. The other piece of this that Tom referred to, I went down to my office, my colleague Rob Gold, I was telling him about Tom Cremich's crazy idea. And he left my office and came back almost immediately. He put on my table a model of the Ulysses spacecraft. And he said, that's what the spacecraft should look like. And I looked at it, here's this triangular body with an antenna on top, with an RTG at one apex of it. And it looked, yeah, you almost said, yeah, you're absolutely right. So within hours, an hour of being told, if we're going to do this, I knew what the spacecraft was going to look like. And it looks like that. Well, we needed instruments. We needed to understand science. So we brought Andy Chang along. And I think Tom was one of the people saying, you need to get a hold of Andy. So Andy was one of the scientists in our department. He'd been working with Alan and others on the Pluto mission. So he understood the science requirements. He could help us understand what kind of instrumentation we would have to fly. So we got a guide idea of the instruments. We got an understanding of the spacecraft configuration. Okay, we need the rest of the systems will make the spacecraft work. Andy Santos had been the mission systems engineer on the NEAR mission. So we brought him aboard to help us fill out the system aspects of the mission. We brought Marty Freeman aboard to understand about some of the electronics we needed to fly. He brought us the ideas of the solid state recorder that we needed, about using non-volatile memory for a command system. And he brought those pieces that were also critical to a mission. And it turned out to be part of our key pieces of the mission we flew. I was worried about thermal. So we brought Doug Behoke along. And Doug said, no worries. We're going to make the spacecraft look like a thermos bottle. It'll stay nice and warm. And so it has for 20 years. We had one other challenge. As we alluded to this, we needed to fly a radioisotope thermoelectric generator. Well, those take about 11 kilograms of plutonium, which creates all kinds of launch safety issues. Cassini had these on board it. It took them 7 years to get launch approval. We had 4. So we brought Yale Chang on. Yale had been working with DOE on launch issues and launch safety issues, so he knew kind of where the bodies were buried. So he helped us find a path to get launch approval in the time we had. So this is the team that came together with a few others that we went down in 2 weeks and made the pitch to NASA about how we were going to do a Pluto mission. So that's how the concepts came together, and those basic concepts I will talk about next Thursday in more detail, how we got from this concept to actually the launch pad. And of course, this is what it looks like. Here's a picture of the spacecraft as it was being finally tailored with the thermal blankets at Kennedy Space Center a few weeks before launch. We talked about near-death experiences. I'll tell you one. I'll talk some more about others on Thursday. We were assembling the launch vehicle in November. There was a hurricane. So they were assembling the solid rockets, propellant rockets that were part of the launch complex. And they had 3 on and they had 2 more to go. And they closed down just in time before the hurricane. Well, I thought they had another day or so. And I was thinking, I was out there and I was thinking, hey, they have time to put at least 1 more of these on the launch vehicle. The hurricane came through, it tore the door off the assembly building and damaged one of the solid rockets. We had 1 spare. So if we had put another solid state on that vehicle, we could have easily had 2 damaged. We wouldn't have launched. So those are some of the near-death experiences that you have that you don't account for. So I want to finish this and then hand it over to Alice. This is a image of the path of New Horizons out to the solar system that I think Leslie Young actually put together. And I like it because you can see where all the planets were moving as we were traveling out. So, of course, all the inner rocky planets were going round and round and round over these 9 years. But we flew by Jupiter just in time to get that extra push. And in that first year, we had to commission all the instruments, check out all the functioning of the spacecraft, and then build up a complete complex set of observations to demonstrate that the spacecraft could actually perform as we want at Pluto. And it came off spectacularly, as many of you remember. We then understood that we needed more time to do the Pluto encounter. And so this is a story that Alice is going to tell you, and I'll turn it over to Alice.
I'm just supposed to see. Oh, there they are. First of all, I would like to say what an absolute honor it has been to fly this mission across the solar system. You guys were always there for us. Alan, especially our big Apollo 13 moment. I remember you trusted us and you let us do what we do best. So I just wanted to say that it's definitely one of those things in my life that it sort of defined me as a person. So thank you. And I know the ops team is just, the same. We love flying the spacecraft. So I thought this is a new slide for me. I thought I would go through and see, well, what actually did we do during cruise? Because I remember before launch, people saying, oh, it's a long time to Pluto. What the heck is the ops team gonna do all this time? Well, we did 8 TCMs, which when you think about 9.5 years across the solar system, that is not a lot. You know, that rocket was absolutely wonderful. It got us into a launch injection that was pretty close to perfect. So we didn't have to do too many. We had 11 autonomy software uploads. We have 5 onboard computer updates, which I think is pretty amazing. 18 hibernation periods. So the spacecraft spent about 66% of its life of the mission to Pluto in hibernation. And this was, you know, perfect for us. We had a small team. And so when we were in spacecraft was in hibernation, the operations team and the science team and the engineering team were all working on the sequence that we're going to fly at Pluto. Chris Hersman was giving this awesome task of looking at all the possible faults that might occur when we were at encounter, and he kind of narrowed those down to 237 faults. And, you know, it sounds like a lot, and it is. We went through every one as a team, and we decided how we're going to disposition them. Some of them we didn't think were that feasible, so we kind of just wrote on paper, well, we'll deal with it when we get to it. Others that we thought might be more involved and had maybe a higher probability of happening, we kind of went into detail of what we're going to do. And you should ask me in a couple slides to recount what one of those 237 faults was, and if we followed what we said we were going to do on paper. Ask me, I always forget to tell people. We had 4 in-flight rehearsals. We had hazard campaigns because after that second moon, well, there were 2 moons discovered, 3 moons. Karen, Nix, and Hydra that were pretty close to, you know, before we launched. And then there were 2 other moons that were discovered after we launched, and we were well within planning the sequence for encounter. And, you know, I can remember Hal said, Alice, we found another moon, Kerbos. And we said, oh, great. And then he said, hey, we found another one. We're going, uh-oh, we know what that means. We're going to have to do another sequence. That was what that was going to mean. So, you know, we were very, very busy. We had lots of ORTs on the ground and, of course, with the spacecraft. So, ops team not busy. There we go. So I mentioned before that we do build these 2-week sequences, and we had defined some sequences that were more important than the others. So we had 13 sequences that we built from January until June, and then we had these critical sequences that we sort of pre-built, and they weren't completely finished because we had to lay in the DSN tracks and some of the clock kernels and things like that. But for pretty much, they were pretty much tested, and we only had to do a little bit of things. And then we had these sequences, extremely critical sequences, the core and the GIS sequence that took care of the observation sequences or observations from this 9-day load from July 7th to July 16th. And the GIS, these moons that were discovered, they're pretty much responsible for the reason that we had to go with the GIS sequence, the generic inner sequence. And those were just in case we had to protect the spacecraft. And so this is kind of a pictorial of it. These were all the different trajectories that we thought we could fly by and sort of miss any kind of debris field that might show up in these hazard observations that we were doing. But it turns out that we did not have to fly those trajectories. Fly the SAFE sequence, the GIS sequence, because it actually took out 4 hours of our very important Pluto science observations. And so we were very lucky we could fly everything on the core sequence or the nominal sequence. And so, you know, here we are in the ops team. We've done all these TCMs, we've done the flight loads, and, you know, June 30th comes along and we get information from the OpNav team that tells us that we do not have to do that last TCM placeholder that we have. And so the ops team sends up those commands to disable that TCM. And then on July 2nd, we got a note from the team that was looking at the hazard observations, and they said, we don't see any hazards, which means moons or rings or something like that, where we would have to use this less than optimal sequence where we pretty much take 4 hours out of this observation sequence and miss some extremely wonderful science. So we find out that we don't have to do that. We can fly the nominal sequence. We can do all those observations. Leslie told me the other day there was 441 observations in that that 9-day sequence. On July 3rd, we were clear to upload the sequence to the backup processor. We had to load a sequence to the backup processor and one to the primary processor in order for the autonomy, if it found a fault, it could reload everything from flash. So we had to have it on both sides. So we did that on July 3rd, and we verified it. July 4th was the first opportunity that we could load the sequence to the prime processor, because that's the point when the memory was clear and it would be able to hold all those 441 observations. And so at 4:30 in the morning, Alan, I know, was in the ops center about 4:30. I think it was 4:23 or something like that. One half of our ops team was there in the ops center loading. I'm looking over at my ops team over here, loading the sequence to the through the DSN. 2 hours to radiate that, because we're actually sending it up to RAM and then we're commanding it to burn to flash. Let's see this next slide. Round trip light time on this day was about 4 hours, 4.5 hours one way. So time it would take to radiate from Earth to get to the spacecraft, about 4.5 hours, and then another 4.5 hours before we get what we call the command echoes, or we see what the computer processor has accepted and how it's gone into memory, if everything looks okay. So round trip light time later, the other half of the ops team is in the Mission Operations Center about 1:10. Everything looks like it's going just fine. 1:54. The whole atmosphere changes. Total loss of calm. Nothing. Gray screens. You know, we're looking at each other thinking, oh, must have been a DSN glitch or something like that, because that's a very complicated system. We checked that. It was all fine. And we thought, gee, here we are, you know, 9.5 years we spent getting here. And it's our one chance. It's a flyby mission. We only have one chance. And we're having a real problem. So we start our call tree, you know, get people in. It was July 4th. Before the first people started arriving from outside, our autonomy engineer, our main computer engineer, chief planning engineer, Carl, we were working on it, and we narrowed it down to 2 faults. One, a processor reset that we had seen before in the past that takes about 109 minutes to recover for autonomy to get us back up the spacecraft and sending a signal. The other one, which we'd never be seen before, but was on Chris's 237 fault, was a bus controller swap or a processor swap, where we switched from the main computer to the backup computer. And the time on that was about 50 minutes. It would take the autonomy system 50 minutes to do that switch and start putting out a signal that we could detect. So we were, you know, about 77 minutes or so into no comm with the spacecraft. And so our flight controllers configured the ground station to be on that frequency at that polarization. We locked up to the spacecraft. Thank God. We were alive, the spacecraft was talking to us, but it was at 10 bits and spinning. You can't do a flyby and take science when you're spinning. We've got a spinning spacecraft. So we spent the next 2.5 days, because that was all we had, recovering the spacecraft. And minutes before that 9-day sequence was to engage, we saw that the spacecraft transitioned to a 3-axis mode. We knew we were on our way to Pluto to get excellent observations, do all the science that everybody had asked us to do. And this, the first image, it's blurry, but we love it. Okay, so, phew, now, fast forward. So July 14th, you know, our spacecraft, very small, very agile, it cannot be in communication with the Earth when it's taking science observations. So the idea was, down at the bottom of the page is the last track or contact we had was with the Madrid station, where we're checking on the spacecraft, making sure it looks okay. And then on this yellow arrow, the trajectory through the Pluto system, the spacecraft's going to fly for about 22 hours, and it's going to do science, only science. At the very top of that picture, we're going to pause for about 15 minutes. Spacecrafts turn back around and shoot us some information, not any pictures, just telemetry to tell us, do the recorders look full? Does it look like they collected all the data we wanted to collect? Is the spacecraft healthy? Is it talking to us? So this next is a quick video that I think it's one of Glenn's favorites. Let me see, I think I have to click it. On here? Okay. So this tells you, it's sped up. It's 22 hours and 20 seconds. And it shows you all the different observations that it's doing. You can see the instruments up here. You can see the distance, you know, what it is imaging. And then it's turning around and looking back and collecting that beautiful picture that Alan likes. So this is what our little spacecraft does in that 22-hour period. So then just to remind you where we are, I'll let it go by one more time. Okay. So here we are, we've flown through the Pluto system. This is the most treacherous part of our journey, because there are hazards that yes, we did look for those hazards, but there's only a certain limit that we can detect. So, you know, we don't know. So we get to the other end, and this next is just a shortened video of in the Mission Operations Center when we were configuring for that track, and you can see the people come in afterwards, Ellen and, oh, sorry. Okay. I'm not doing well.
And lock on symbols.
So that's the first step for getting data.
Okay, copy that. We're in lock with telemetry with the spacecraft.
A lot of green numbers in that. Oh, man. Green is good. Yeah. Gotta get that, man.
Hey, PI, Mom on Pluto 1. We have a healthy spacecraft. We've recorded data of the Pluto system, and we're outbound for Pluto.
Yeah. That's it.
Yeah, so it has been quite a journey. Um, Thank you, everyone. And you give us a job, we're going to do it, and we're going to do it to the best of them. So thank you very much.
Geez, Alice, I don't even know if I can give my talk. I get post-traumatic stress from that July 4th experience. How many therapy sessions did you have to have after that to get? Anyway, I thought it'd be fun to, maybe do a little reminiscing about what it was like before, what we knew about the Pluto system before the New Horizons flyby, and compare that to what was revealed by the New Horizons flyby. And so on the left here, you have a photo taken from the best optical telescope we have, the Hubble Space Telescope. This is a Pluto family portrait, over 100 minutes of exposure time. Remarkable technical feat, actually, showing all 6 bodies in the Pluto system. If you recall, there were only 2 objects known in the Pluto system when the proposal was accepted, Pluto and Charon, the binary, Charon being discovered by Jim in 1978. But Hubble allowed us to discover 4 more small satellites. And Pluto was transformed into its own mini solar system. And the little diagram to the right shows you the relative placements of all those satellites circulating around Pluto. So that's fantastic, but they're all kind of pinpoints of light. Although this is the best image of Pluto obtained from Earth orbit. Of course, you're 3 billion miles away, and this is pretty good. As Alan said, Alan took this picture. And, but it's, we're getting very excited by this and tried to squeeze as much science as we could out of images like this. But this is on the same scale. After the Pluto flyby, you're completely transformed this pixelated blob into an incredible, vibrant world with such complexity and diversity. So, this is about, let's see, so I guess it was about 7,800 miles away, flying above Pluto's surface. And so you have to go there to actually see what these objects look like. It's the lesson of space science. And this is the new Pluto family portrait. After the New Horizons flyby, you've got beautiful Pluto, but you've got this incredible pictures of Charon. And instead of just being little specks in a Hubble image, we now even resolve those small satellites, the 4 small satellites. Now, what I want to do next is show you a movie comprised of some of the images that we took during the Pluto flyby, but put together in a movie that gives you the sense of almost flying over Pluto. And so it starts down in the southwest edge of Sputnik Planitia, that giant nitrogen ice glacier. But here, down in the southwest, you've got cryovolcanic regions, material coming out from Pluto. Over to the left, you have this dark red equatorial belt. It's really ancient, pockmarked with craters. And now I look off to the right with all these mountain ranges, water ice mountains as high as the Rocky Mountains in the United States. And then you see Sputnik Planitia with these beautiful polygon-shaped regions all throughout, but really young region, fresh, couldn't find any craters on the surface. So just spectacular and really completely unexpected. I remember being here for a conference a few years before the Pluto flyby, and one of the top geophysicists here in our country was saying that, I hate to say it, but it's going to probably look like a billiard ball. There's just no processes that can produce what we just now saw. And, so you get these surprises. And I just wanted to highlight one thing. This is that dark red region in the equator of Pluto, which is just chock full with organics. We've looked for decades for any organic material on Mars, but here it is, just these, we just generically refer to this as Tholen type material. We don't know chemically exactly what it is, but lots of organics. But then there's that little red stringy thing up there that's a water ammonia mix leaching out from the interior of Pluto that is a hint that there may be an ocean underneath. So some astrobiology possibly on Pluto. But not just Pluto. Of course, we got just beautiful Charon here, just with this incredible craters, huge craters, dwarfing the size of the Grand Canyon of the United States, across almost encircling the entire equator of Charon, produced almost certainly shortly after Charon's formation, when it still had liquid water, but the liquid water quickly froze. And when water freezes, it expands and almost splits the surface apart. You have this, to the right is a digital elevation model, so an altitude map across Charon. The full range is about 10 kilometers, so 6 miles, topography on the surface of Charon. But there's also that red hood, polar hood. We think there's also one on the southern pole that you can't see. And we think that's produced by methane molecules escaping from Pluto and being captured in the coldest regions of Charon, the poles. And then this is relatively clear methane ice that then gets processed by radiation to turn it into this red material. And not only do we see beautiful Pluto and Charon, but we also actually get some substantial information about the small satellites. To the left is a diagram showing the trajectory of the spacecraft through the Pluto system. And you see we actually pass fairly close to Nix, one of the satellites, and producing that beautiful color image in the upper right, where we could actually count craters on the surface and had a color image so that we could, do the correlation between the composition and the morphology, and had a nice image of Hydra as well, and even resolved both Styx and Kerberos, especially with the help of Todd Lauer deconvolving the images. Alan loves that shot of Pluto's blue atmosphere, blue sky, but I think this is one of the most iconic views in planetary science. After we flew by Pluto, looking back towards the sun is into the page. Holy crap. You look at this and you see the mountains and the shadows of these high mountains, this different view of the giant Texas-sized, nitrogen ice sheet. And then looking along the horizon, that's not noise. These are just bands, aerosol bands, many of them, 10 or so. Yeah. Pluto the planet, it's really a planet. Okay, so just awe-inspiring. I think that, and, here's Alan's favorite, the Pluto blue sky. But it wasn't just us who were excited by the results from the New Horizons mission. We excited the entire world. More than 450 front pages of newspapers, including the New York Times, that picture to the left. 1.7 billion mentions across 21 social media platforms. And just on Facebook alone, 144 million people. This was a great public relations extravaganza for NASA and for science in general. So, thankfully, this is what New Horizons returned for us. Oops, went back, need to go back one more. And this enabled us to get the post office to change the old stamp where Pluto was unexplored, and the little spacecraft, New Horizons, is now completely transformed Pluto. It has been explored, producing the stamp to the right. Thank you.
Good news is we're almost done. The bad news is you have to listen to me again, but only for a few slides. And Mike tells me that he wants to give you guys a chance if there are a few questions, but we also know it's running late. And so I do have about 5 slides and just a few things to say, much more general. And then I want to tell you about a couple of texts that I received when I sat back down while I was up here speaking. So let's do the slides. And so I want to remind you that we are continuing on. We have been flying now for 10 years since the Pluto flyby. We are more than twice as far from the sun as we were when we did that flyby. From the beginning, when we proposed, NASA and the National Academy made clear that this was not just a mission to be the first to explore the Pluto system, but also the Kuiper Belt. This is the third zone of the solar system, beyond the terrestrial planets and beyond the ice giants. And in fact, when the decadal survey from the National Academy came out, they called the mission Kuiper Belt Pluto and said, we did this for a reason. We put Kuiper Belt first because it's higher priority. Pluto's high priority, but it's really this third zone that we want to see reconnoitered. And so all the proposing teams had to show that the spacecraft would have the longevity and the power and the comm range and the fuel to do all this, to keep going for many, many years and to do as much Kuiper Belt science as possible. And so as a result of the last NASA process to evaluate extended missions, that's called the senior review, we were extended through 2029. And we are now in the middle of that extended mission. Many of you are part of this team, but others may not know that we have now studied a whole variety of things in the Kuiper Belt. We've studied dozens of Kuiper Belt objects, and that includes several dwarf planets like Pluto. And we've had a close flyby of one Kuiper Belt object that we zoomed right up to. If you think this was something in 2015, we give ourselves a little bit harder task in having the flyby of a Kuiper Belt object, because instead of flying by something the size of North America, more or less, that's Pluto, we flew by this tiny little building block of a planet. It's only this big. There it is to scale on Pluto. And we had to hunt it down in the dark, where the light levels are 2,000 times lower than they are outside during the daytime. And the same team of people that brought you the Pluto flyby spectacularly accomplished this one-shot flyby 4 years later in 2019. And that science was just as important, I think, as what we learned about how active and diverse small planets can be, because it really gave us answers to how the seeds of planets are born. I'm not going to go into that story tonight, but just like Pluto, we made the cover of the Rolling Stone for nerds called Science. And just like the flyby of Pluto, it really was all about the people. It really was just as big a challenge with just as high as stakes, an older spacecraft, an older team, some unique technical challenges that we did not have at Pluto. And for me, it was scenes like this that meant everything. When people knew we had done it, we had pulled it off. That's what it's like to be on a spacecraft team that works together, right? It's really people who band together and do something larger than life that no single human can do, that you can only do because you're working as a team. And so the mission of New Horizons continues. We just love to get another flyby target. We're looking very hard with the very best tools that are available. A new tool called the Vera Rubin Observatory just came online. And we have lots of other science too, but I'm not going to go into that. I know it's getting late. I just want to thank everybody on the New Horizons team, whether you're online tonight, or whether you're here in the room, for making this the dream mission of a lifetime for me. And I think dream mission of a lifetime for most of you. I've had so many people on this team tell me over the years that they never worked on anything like this, and I feel the same way. I've been on 30 space missions, 29 of them robotic, and I got to fly in space in 2023. This is the best one ever. I want to close by telling you now, Mike's going to have time for a few questions, but I got these 2 texts while I was up here at the podium, and they're almost completely by coincidence. So let me find and read you the first one. It's from my son. His name is Jordan. And he just happened to text while I was speaking. And I'll read you the whole text. It's only 3 or 4 sentences. Hey, Dad, I'm back from Toronto as of a few hours ago, reflecting on the 10th anniversary of the Pluto flyby. I have not mentioned this trip to him, by the way. He just happened to be aware. He said, hard to believe it was that long ago. What a special and historic day that was. One of the most remarkable days of my lifetime. Did you do anything special to celebrate the occasion? I sent him pictures. You may have seen me taking pictures of the crowd, of all of you. Almost simultaneously, I got a text from Cindy Conrad, who's here in the room. Where's Cindy sitting? Over there. And Cindy pointed out what a historic occasion it is to have all of you in the room. And I feel like a nut for not thinking of it, but fortunately Cindy did. And she said we should all get a group picture. So after the Q&A, we're going to do that. If you can stay, we really would like to get a group picture. In fact, I'd like to get a couple of them and at least one doing the Pluto salute. So I just want to reflect on a little bit on exploration, then I'm going to hand it over to Mike. You know, humans are the only species on this planet that are explorers. It makes us completely different from everything else that the Earth has invented in terms of life forms. And it's an amazing human imperative, stretching back thousands, if not tens of thousands of years, maybe even further, to some of our ancestors and through multiple civilizations, Western, Eastern, African, all across the planet, there have been explorers of land, sea, air, and now space. We live at a very special time when the solar system is opening up to all of humankind. More and more countries and even companies are becoming capable on their own of doing space missions. The hardest ones are the ones that NASA does, like flying across the solar system to the last planet discovered in the 20th century. It was an amazing opportunity for all of us to win that competition in 2001. And the stakes were very high. Tom described some of what went on. Getting canceled multiple times after being selected was just one of the challenges that we faced. But this team never gave up, and we're not giving up now. It's our job to explore the Kuiper Belt. We've also taken on the challenge of the heliosphere. And I couldn't be prouder of this team. Its resolve, its heart, its dedication, its ingenuity that have together produced something really historic. I think most people want to leave the world a little better place when they're gone. And I know when I think about my lifetime, it's this project. It's probably the biggest contribution I will ever make. Thank you all for it. Mike, over to you.
There's ambition, right, that we've heard tonight to send a mission decades in the making across the solar system. And there's also ambition to think you could tell that story in under an hour. I'm glad we succeeded at the first. It's not such a big deal that we failed on the second. I'd like to say, though, I would like to open it up just for a couple of questions if anybody has some for the panelists. If we have the microphones here available, if you have something, I'd understand if not, because we've been here for a while. So yeah, Paul's got something.
Hi, yeah. I've made maps of bodies from the moon to Triton and beyond, and I have to say, Pluto, especially the topographic maps, are my pride and joy. But my question is, several speakers mentioned the mission concepts that came before New Horizons, the Pluto Kuiper Express and all those other ones. I was struck by the fact that several of them were half the weight of the mission that we flew. What kind of missions were those? What kind of payloads could they have carried? Does anybody remember that? I guess you remember then.
I know, yeah.
All right, I'll take it. Should be. Does that work?
No, you can turn it on. You have to push a button.
Oh, I have to turn it on.
Yeah, you have to turn it on.
It's on now.
Yeah, there's.
Okay, I think it's on.
Yep.
Yeah, I was on study teams for every one of those missions that never got off the drawing board. Ralph McNutt and Fran Bagenau and Bill McKinnon, who were here in the room, were also, I believe, on all of them. And it was all over the map. There was something called Mariner Mark II that was like a houseboat to Pluto, a Cassini. And then there was a Pluto, what was it? Pluto Express. That was like a hamster. The plan was to send just a camera. And so they were all over the map, but I will tell you, none of them had the sophistication of and the range of scientific instruments that we had, except Mariner Mark II, which was completely unaffordable. But even that mission did not have the giant solid state memories that New Horizons flew, so we could take a lot more data in a single flyby than had ever been possible, 100 times what Voyager would take in a flyby. And so we really ended up with the best solution, even though we went through a lot of travails to get there by being delayed all those years and getting to a concept like New Horizons that APL invented.
All right, anyone else? Okay.
So 10 years ago, when we were in this room and hearing the callbacks, as in our light cone, New Horizons flew past, I distinctly remember my favorite moment was when they called out nominal thruster count, because it meant that we did a nominal flyby. But I was important, but it also meant that we still had fuel left over to do a flyby of a Kuiper Belt object. And I just have to have massive thanks for the ops people forever, because there's such a perfect flyby. They used the fuel they needed and nothing else. So we were able to go to Arikoth.
Anyone else? Back there, there's a couple I see here. Sorry.
I just wanted to add to that, when we were in here that night, just one of the things that I got from people who were visiting, who, I don't know, I've never seen before, so I don't think they were part of the team. But the way we knew that our signal had passed Saturn, past Jupiter, I don't think I've ever in my lifetime had the kind of sense of the scale of the solar system with that coming. And what an educational tool. I mean, sure, what we discovered, but the way that this mission, and looking at you, the way that our communications worked and we presented it, I think is just historic. And thank you.
Oh. Well, it's definitely a story that told itself, right? It was amazing. What an opportunity to see that. I mean, you're uncovering a world for the first time. I love that Hal showed that one slide, which is the impact, right? Where was the goal? Let's get above the fold in the New York Times. And it was the New York Times and then some to see all that. What a magical experience. What an incredible thing, though. I still have goosebumps watching that video, too, with the call that New Horizons was safe and had done everything it was. An amazing thing.
So I just wanted to add one more story. So the night before the big announcement, there was a few of us in the room, and our job was tasked. So MVic had taken a color image of Pluto, and Laurie had taken a black and white image, but they were taken at slightly different times. So Pluto had rotated underneath us, and our job was to put the color image on top of the black and white image, and it was Simon Porter and John Spencer, who's not here, and Hal, myself, and Alex Parker, who's in here, and Todd. That's right. And and it was just it was a long night, but it was this privileged moment. And I remember we were waiting for the images to come down, and we knew when we thought, and Alex and I had gone out to dinner, and we ran into Bill Nye, the science guy, and he was like, do you want to join us? It's like, no, I'm sorry, we've got Pluto stuff to do. Like, never in my life. I grew up on Bill Nye, the science guy. I thought I'd say next to him. And we came back in, and Hal is always the sweetest guy, right? I'd never heard him say a swear word, a curse word in his entire life. That first image of Pluto came down. And I heard some curse words out of Hal's mouth. And it was completely justified because our jaws just hit the floor and we knew we had a job to do, but we all spent the entire time going, did you see the thing? Okay, no, we've got to do the thing. Like type. And those 4 hours or whatever it was just one of those moments that I will hold on to for the rest of my life. It was one of the best moments ever. So thank you to everyone that shared that and enabled it. And we got to communicate it. And it was just to make something and then have the president retweet it 6 hours later. Like that, you've hit the big time. It's never going to be as good as that again. But it was wonderful. So thank you, everyone. And thank you, Hal, and everyone else. It was brilliant. Thanks.
Let's squeeze a couple more in. Almost got one.
So when we going back? My map's not finished yet. I haven't finished coloring in. There's this big black area. Here be dragons. But I will say, do not underestimate Pluto's capacity to surprise us. I know if when humanity goes back, we're going to see some more weirdness going on there. So who knows? It'll be in any of our lifetimes, but I would truly love to be there to see it.
Do we have to bleep this out? Do we have to get the?
Okay. So I go back to the very beginning with Alan. I remember him as a grad student coming to me.
Yeah, sure.
Bullshit, yeah, right. So Alan, when I was starting to teach after Voyager flew past Neptune. And of course, all the Voyager team was like, now what? Now what do we do? Alan came up to me and said, we go to Pluto. And I was like a giant planet person. I said, Pluto? Who gives a toss about that tiny little planet? I'm a giant planet person. I work on magnetic fields. Who cares about Pluto? But he persuaded me. And we spent 12 years campaigning with NASA. And I remember very distinctly Bill McKinnon, when we first detected these objects with Pluto in the Kuiper Belt. And he was saying that we were in Boulder and he looked out at the mountains and said, beyond those mountains, there's a new world. And the same way, beyond, there's this new world beyond Neptune. Let's go there. And I was like, okay, let's go there. But I was expecting we were going to find a Callisto, right? This boring object covered in impact craters, geology, boring. Who gives a toss? Boring. And then we got those pictures, and then we had that picture with the planet with all that stuff. I mean, geology and atmospheres and space physics and everything. Amazing, phenomenal, incredible. Okay, but I have to say, the most important thing is when I go give public talks, and I've given many public talks on this topic, particularly Pluto, the kids are excited. They love Pluto and they are curious, they are excited, they're involved. And I think this is the most important thing that we have done, is we've gotten kids to do their math homework because they're excited about Pluto. And this justifies all of the budget that we've had, every single penny, every single cent, to justify the kids' excitement to go explore Pluto and do their math homework. So thank you, Alan, for persuading me that it was worth going. Absolutely.
Thank you, Frank.
I can't think of a better way to wrap that up. Thank you. We do. Thank you. And I want to thank the panelists again too for all the presentations in this and taking us back in this amazing journey. And don't forget, if we pick the spot, we get together for this picture and get everybody together. Just remember this moment. So thank you again for being with us here tonight and taking this special journey with us.